Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్, న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma నుంచి స్టార్ట్ అయిపోయినాయి, సెకండ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది, థర్డ్ ఇయర్ డిప్లొమా స్టూడెంట్స్ కి స్టార్ట్ అయిపోయింది. 3 years కోర్స్ ఉంటుంది, 2 years కోర్స్ ఉంటుంది, 1 year కోర్స్ ఉంటుంది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో Saimedha Koti Hyderabad is providing every year coaching. రిజల్ట్స్ విషయానికి వస్తే you know it, guys, every single year top 5 branches లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై Saimedha Koti Hyderabad only. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. ఎఫెక్టివ్ కోచింగ్ ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్, ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ as ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Let us solve question number 11. The question is, in a 4-pole 36 slots, a DC armature coil span of 180-degree electrical will be obtained when the coil couples 1 and 10 slots and 1 and 9 slots, option 3 2 and 9 slots and option 4 3 and the 10 slots. Okay, so first one given that, okay, given in the question the number of the poles P is equal to 4 number of the poles and number of the slot S is equal to 36 slots and 180-degree electricals coil span of the winding. So now let us find out the pole pitch. The pole pitch is equal to pole pitch, so that is the slots per pole. Okay, slots per pole means the 36 by 9. So now it is equal to 36 by 4. So now it is equal to 9 armature slots. So these 9 armature slots is equal to 180-degree electrical. We know that pole pitch is always equal to the 180-degree electrical per any pole pitch. So given in this question, coil span is equal to 180-degree electrical. So now this is a coil span of the winding. Suppose, so we have A, the B and this one is the CD. So starting end and the finishing end. So this is the coil, the span of the winding. So this is equal to 180-degree electrical and also 9 armature slots. Okay, this one is the 9 armature slots in the arm. So what are the 9 arms? Suppose let's see the first one, option number 1. So now first and 9 slots. Now what about the number of armature slots in between these two? So 9 minus 1, so 8 armature slot. Now in the option number 3, the 9 and 2. So 9 minus 2 here, this is equal to 7 armature slots. And in the option number 3, 10 minus 3, so it is this is a 7 armature slots. And 1 and 10, so 10 minus 1, the 9 armature slots. So which option? So this 9 armature slots is equal to 180 degree electrical coil span. So only option 2 is a possible. So that answer for this question 1 and 10 slots. Okay. And next one, question number 12. The function of the commutator, okay, in the DC machine. Option 1, to change alternative current to direct current. Option 2, to improve commutation. Option 3, for easy speed control. And option 4, to change alternative voltage to the direct voltage. So function of the commutator in the DC machine is to change alternative voltage to the direct voltage. So option the 4 is correct for this question. So commutator is a rotating part of the machine. It is made with a hard drawn copper material. Sometimes we have a question. So hard drawn the copper material. So to reduce the wear and tear losses. So hard drawn copper material, so to reduce the wear and tear losses. The number of commutator segments always is equal to the number of the armature coils. So this is also one of the question. And mica insulation is used between the laminations of the transformer core. So in case of the generator, okay, in the DC generator, so DC generator point of view, commutator converts the AC voltage to the DC voltage. And next one, in case of the motor point of view, so this is the converts, okay, DC to the AC voltage, okay. Next one, so now in this case it acts as a converter, okay. This one is act as a the inverter point of view, okay. In case of the DC generator, commutator converts the AC to the DC, act as a converter. In case of the motor, commutator converts DC to the AC, act as an inverter. So commutator is treated as the full wave, okay. This one is full wave, so uncontrolled, so this uncontrolled rotating rectifier or mechanical rectifier, the rotating rectifier. So got it. So this is also one more possibility of the question from the commutator concept. But in this question, what is the answer for this question? Just function of the commutator. It is changed to alternative voltage to the direct voltage. So option 4 is correct for this question. And next one, question number 13. If n is the speed and p is the number of the poles, then the frequency of induced EMF in the DC generators. If n is the speed and p is the number of the poles, then the frequency of the induced EMF in the DC generator will be option 1 NP by 60, option 2 NP by 120, and option 3 NP by 2, and option 4 NP. So we know this is a relation between the electrical angle and mechanical angle. The relation between electrical angle and the mechanical angle. So electrical angle is a theta E and mechanical angle is theta M. So what is the relation between these two? So that is P here, electrical angle is equal to the P by 2 mechanical angle. So differentiation of the electrical angle with respect to the time is equal to P by 2 the differentiation of the mechanical angle, so with respect to the time. So now change in the electrical angle, change in the mechanical angle. Change in the electrical angle is the omega E, the P by 2 the omega M. So now by using this equation, the here omega E is nothing but, okay, this omega is a angular frequency, okay, this one is a angular frequency, and omega M is a angular speed, okay, this is the angular speed here, and angular frequency omega is 2 pi the f, and is equal to p by 2. Angular speed is equal to the 2 pi n by 60. So now in this case 2 pi, the 2 pi will be cancelled. So f is equal to pn by 120. So where p is the number of the poles, in this case p is number of the poles of the machine and n is the speed in the rpm, revolutions the per minute, rpm one. So now answer for this question, option 2 is correct for this question. Np by 120, frequency of the induced EMF in the DC generator. So always f is equal to pn by 120. Okay. And next one, question number 14. In DC generator, the rule is used to know the direction of induced EMF is the screw rule, thumb rule, Fleming's right hand rule and Fleming's left hand rule. So in DC generator, in this case, so DC generator's point. So now EMF induced per conductor. So EMF per conductor. So that is equal to the BLV, the sin theta. This is according to Faraday's laws of electromagnetic induction. Whenever a rotating conductor is placed in the stationary magnetic field and EMF induced in that conductors. So how do we find out this direction of induced EMF? So direction of this direction of the induced EMF in the DC generator can be obtained by using the Fleming's right hand rule. The Fleming's right hand rule. So that is FRR. What is the Fleming's right hand rule? So if the forefinger, center finger and thumb of the right hand are stretched in a perpendicular direction to each other, if forefinger indicates direction of the flux, thumb indicates force applied on the conductor or rotation of the conductor, then center finger indicates the induced EMF direction or direction of induced current. So assume the diagram point of view, suppose this one is a, so this is a, let us assume it is a forefinger and this one is the thumb of the right hand and it is the center finger. Okay. Now this is a, in this case the forefinger indicates direction of the flux. So thumb indicates force applied, force applied on the conductors. So this center finger indicates induced EMF, or the induced, this induced current. So now this is unknown parameters, it is unknown. So remaining two are known. If we know these two, we can find out the third one. So direction of induced EMF in the DC generator can be obtained by using the Fleming's right hand rule. So option the 3 is correct for this question. And next one, question number 15. A lab-wound DC generator has 40 conductors and 8 poles. The voltage induced per conductor is 2 volts. The machine generates a voltage of. So given in this case, the option 1 is 200 volts, option 2 is a 400 volts and option 3 100 volts and option 4 800 volts. Now given that lab-wound DC generator and also number of the conductors is mentioned. So given in the question, the given that the number of the conductors, number of the conductors, so Z is equal to 400 conductors. How many number of the poles? Number of the poles is equal to 8 number of the poles. And also this induced voltage, the per conductor is given. So this one is the induced voltage per conductors. So this per conductor, this is equal to the 2 volts. Now this is the number of parallel paths. A is equal to lap winding. So that's why A is equal to P, 8 number of the parallel paths. Now let us find out first one. So induced EMF, this induced EMF per conductor. So this one is a, per this conductor is equal to BLV. So this BLV values. Now induced EMF, induced EMF. So per parallel path, this is the parallel path. So that how do we get this parallel path voltage? It is known as denoted by the EZ value. So that means induced EMF per conductors, okay, this per conductor. Now how many conductors per parallel path? Z by A conductors. So this one is the induced EMF per conductor is equal to, so now the parallel path. So number of conductors per parallel path. So induced EMF per conductors. Now this induced EMF per conductor is equal to the 2 volts, and how many number of conductors? The 400 conductors. So divided by how many number of parallel paths? 8 number of the parallel paths. Now simplify this. So this value here 2, okay, this 2 and the 2 multiplied by 4 times the 4 into the 100, so that this value is equal to 100 volts. So this formula is very important. So induced EMF per parallel path is equal to the induced EMF per conductors multiplied by the Z by A. So this was given in the question that the induced EMF per conductor is equal to 2 volts. So one conductor that generate the voltage of 2 volts. How many conductors per parallel path? Z by A conductors. So therefore induced EMF per parallel path is equal to, just substitute and simplify, will get an answer. That answer is the 100, okay, this one is 100 volts. So option 3 is the correct for this question. And next one, let us solve question number 16. The number of parallel paths in the wave winding and lap winding of 2 DC generators with the 2 pair of the poles. So 2 pair of the poles each other. So now we have a 2 DC generators. Okay, this is the, it's not a 2 pole DC generator. The 2 DC generator with the 2 pair of the poles. Okay. So let assume option 1 2 and 4 respectively, 4 and 2 respectively, 2 and 2 respectively, and option 4 4 and 4 the respectively. So number of parallel paths in the wave wind and the lap wind. Suppose DC generator, okay, this one is the DC generator. So A, assume as a DC generator A. So now each is connected with the initially wave winding. Okay, it is a wave winding. The nature of the armature winding, the DC generator A. So nature of armature winding in this case. So nature of armature winding. Okay, and DC generator A is the nature of the armature winding, and number of the parallel paths. Okay, suppose first one, and number of the poles. Okay, the number of the poles we have. So now this is equal to 4 pole the piston. 2 pair of the poles means the 2 pairs. Okay, this is the pair means 2 poles, 2 multiplied by 2. So that is the 4 pole of the machine. And next one, DC generator A, and it is a wave winding. So that the number of the parallel path, okay, this number of the parallel path, so that A is equal to always 2. So that's this one is the 2 number of the parallel paths. And next one more generator, okay, same. So this assume as the DC generator. So this is the generator, the B. So this DC generator B is a lap connected armature winding. So this one is the lap winding. So lap winding, number of poles here also 4 number of the poles. But how many number of parallel paths? A is equal to the P. So P is equal to the 4. So that number of parallel paths in the B generator is a 4. Number of parallel paths in the A generator is the 2 number of the parallel paths. So option 1, 2 and initially wave is mentioned, and then after lap. So the 2 and 4 is a correct answer for this question. And next one, question number 17, equalizer rings are required in the lap winding, the DC machine. So to improve the commutation, to filter out the harmonics, to prevent the flow of circulating current through the brushes, and to reduce the armature reaction. So now equalizer rings are used in the lap connected armature winding. Why? Because so here in order to minimize the circulating current which flows between the any 2 parallel paths. So problem of circulating current in the lap winding is more as compared to the wave winding. So that equalizer rings are used to minimize the circulating current. So option the 3 is the correct for this question. And next one, question number 18, the armature core of the DC machine is laminated to reduce, okay, to reduce option 1 eddy current losses, option 2 hysteresis loss, and option 3 copper losses, and option 4 mechanical losses. So eddy current losses occur in the armature core because of its finite value of the conductivity when time varying nature of the current flux is passing through it. So if eddy current losses, so we know that already I have mentioned this one, the eddy current losses is nothing but the I square R loss, okay, in the armature core. So armature core of the machine. So eddy current loss directly proportional to the I is directly proportional to the resistance is directly proportional, inversely proportional to the current. So therefore eddy current loss directly proportional to the conductivity of the core. So by laminating the material, then what will happen? Conductivity of the material decreases. Decreased in the conductivity decreases the eddy current losses of the machine. So the eddy current losses option, the one is correct for this question. And next one, the 19th question, in a machine for the same number of, okay, in a machine for same number of the slots and same current in the armature conductors, which one of the following will induce the higher EMF? Lap winding, wave winding, compensating winding, and the pole winding. So now this is the armature windings, these two are, suppose given two options, suppose here lap winding, okay, this one is the lap winding and it is used for, okay, lap winding is, okay, used for the low voltage, okay, and high current applications, and whereas wave winding, second one, so this one is a wave winding, so it is used for, okay, low, this is a high voltage, okay, this high voltage and the low current applications, okay, this low current applications point of view. So this is the applications. And what about the compensating winding? Compensating winding, so it is not a armature winding. Compensating winding is placed in the pole shoe which is connected in series with the armature winding to neutralize the armature reaction, or this one is neutralize the armature flux. So now here to neutralize, okay, this one is used that to neutralize armature reaction effect, okay, but not the induce here, there is no induced EMF here. And next one, pole winding. The pole winding means just like this is the field winding of the machine. So this field winding is used to create the flux, main field flux in the machine. So these are the given windings, but which winding gives the high voltage? In the question induced EMF is high, so option the 2 is correct for this question, okay. And next one, question number 20, if the number of the conductors and the speed of the lap wound, okay, lap wound generator is double, then the generated EMF will be, option 1 remains same, and option 2 double the former value, the option 3 4 times of the former value, and option 4 8 times of the former value. So now given in this question, number of the conductors and speed are double. So this is the number of the conductor, let us assume. So Z is the number of the conductors. So number of the conductors in the armature of the DC generator, and the N is a generator. So this one N is nothing but the speed of the generator part. So now in this case, the given in the question, the number of the conductors are double. So that means the Z2 is equal to the 2 times of the Z1, and the speed is also double. So that means the N2 is equal to the 2 times of the N1. Now we required what is the change in the generated voltage of the generator. So we know the formula to find out the generated voltage. So where EZ is equal to, so this the EZ generated voltage in the generator is equal to the phi the Z N by 60 the into P by the A. So here flux, number of poles and number of the parallel paths remain same. So remaining only conductors and the speed are double. So therefore generated voltage, so during the designing, this one is not during operation. So now this is the easy from this equation, from the above equation, okay, we can get, so this is the generated voltage, okay, easy directly proportional to product of the number of the conductors and the speed of the generator. So this equation can be written as, okay, EZ2 divided by EZ1, the is equal to Z2 divided by Z1, the into N2 divided by the N1 values. Just substitute the given values in this equation, so we will get an answer. So EZ2 divided by the EZ1, the is equal to Z2 is equal to 2 times of the Z1, so divided by Z1, and N2 is equal to 2 times of the N1, okay, 2 times of the N1 divided by N1. So now in this equation, okay, Z1 will be cancelled, and N1 also, N1 will be cancelled. So now here this EZ2 is equal to the 4 times of the EZ1. So answer for this question. So now here 4 times of the former value. So that option the 3 is correct for this question. Got it?
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. Admissions అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.